Alright, these are the notes on solving radical equations. And a radical just means a square root, or a cubed root, or a fourth root, but we're going to do square roots this year. Okay, steps to solve. Okay, you isolate the radical, so you want to get the square root by itself. Okay, leave the square root on one side and move all the numbers to the other side. Then you undo the radical by squaring both sides. Okay, everything in math has an opposite. So if I take 2 squared, that's 4. So to undo that, the opposite of a square is a square root. So if I take the answer and square root it, the square root of 4 is just 2. So if I square a number, okay, I can undo that by square rooting it, and vice versa. So if I take the square root of x, I can get rid of that square root by squaring it, because the square root of x squared is the square root of x times the square root of x, which is the square root of x squared. Well, the square root of an x squared is just an x. So you're going to use that idea to get rid of the square root. Then once the square root's gone, then you solve the equation like normal, just solve for the variable. Alright, for example, you have this inequality. So if you follow your steps, the first step is to isolate the radical. So that means get the square root by itself. So I want to move this positive 3 by subtracting, leaving us with the square root of x on the left and 7 on the right. Okay, step 2 is to undo the radical, and we do this by squaring it. Okay, the square root of x is the square root of x times the square root of x, which is really the square root of x squared. Well, what's the square root of a number squared? It's just the number. Okay, so when we square a square root, we get rid of the square root, and we're left with x equals 7 squared, which is our answer. X is 49. So if I plug 49 in there to the original equation and I solve it, the left side should also equal 10. Alright, the next example, again, follow your steps. The first one is to isolate the radical, so to get the square root by itself. So again, I need to move this positive 2. I'm going to do that by subtracting. So I'll have the square root of 3x plus 2 equals 4. Step 2 is to undo the radical by squaring, so I'm going to square both sides. Okay. A square root squared just gets rid of the square root and leaves me with everything under it. In this case, 3x plus 2. And on the right side, 4 squared, 4 times 4 is 16. Step 3 is to solve for the variable. So I need to keep solving this equation. And now it's a normal two-step equation. So subtract 2 from both sides. Okay, we'll get 3x equals 14. And then divide by 3. This does not reduce, it does not divide evenly, so that's just going to be our answer, 14 thirds. Okay. Alright, last example. Again, step 1 is to isolate the radical or the square root. So I'm going to subtract 3 from both sides, leaving me with the square root of 5x minus 1 on the left and 10 on the right. Alright, step 2 is to undo the radical by squaring both sides. Okay, so when I square a square root, it just gets rid of it. And I'm left with just what's underneath, 5x minus 1. 10 squared, 10 times 10 is 100. Okay, and then step 3, solve for the variable. So just keep solving like a normal equation. So add 1 to both sides. 5x will equal 101. Divide by 5. This does not divide evenly. It does not reduce, so that's what we're going to leave our answer as, 101 over 5.